received email, or I'm not sure if it is email, but anyway, you can't find the data missing for every student, okay, on the announcement. But I'm sure you will get the email. Okay. So when you look at what tomorrow morning, or see your data, you can't start, but there is two missing data here: the length, okay, of the wall, and also the conductivity of the insulation. The conductivity of the insulation. Okay, those two missing data. It is specified for each student. So every student has different values. Okay. Now, let's see what is the problem. First, we have here like a corridor. Okay, has a roof. The roof consists of two construction elements. First is the brick. There is a brick, okay, at the top, and there is insulation at the bottom. The brick 5 centimeter thickness, insulation 1 centimeter thickness. Okay, so here it is. I need you to calculate the rate of heat transfer through the roof. Okay, using the resistance. We have again, as you see, two conduction and two convection. Convection from inside, convection from outside, and between them two conductions. Okay? So, you know, when you want to calculate the rate of heat transfer using the resistance, okay, you need to calculate first the resistance. For convection, you need convection heat transfer coefficient, H. Okay? For inside, there is H of room, right? For outside, it's not given. So now we have one missing data, right? And you cannot find the Q using the total resistance because you missed some data here. So you have to find another way. What mean another way? Look at the temperatures. Remember when I say when always apply Q delta T over resistance depend on the temperatures? The temperature says we have three temperatures. Temperature of outside, temperature inside, and the temperature as we see here of the surface inside. So you can apply the equation Q equals delta T over the resistance between the room and the surface. Correct? Room has temperature. Surface has another temperature. T known, T fluid one known. The resistance here known because convection. You can calculate the Q in very simple equation. Okay? Very simple equation. Now the first part done. The second part, find the surface temperature at the top of the wall. Apply same relation, Q equals delta T over resistance. Now Q is known and T is unknown. So T is minus T fluid, that is in the numerator. In the denominator, the resistance between them. And all the resistance also known because the only information you miss is the outside, not the inside. Inside everything is fine.
Doctor, with T fluid 1 or with T fluid 2?
As you wish. With T fluid 1, you can apply the bottom resistance. With T fluid 2, you have to apply which is missing. So you have no way to calculate heat, the temperature from outside. Because T fluid 2, yes, known, minus T surface, unknown, divided by the resistance. The resistance is unknown. Okay. So you have two unknowns, T surface and T and resistance. However, if you go from the bottom, from down, T surface minus T fluid 1. T fluid 1 known, T surface unknown. Now you have one unknown, right? Divided by the resistance R2, R1 and Ri, all of them known. Okay. Now, remember when I say known, why? Because the resistance is L over Ka for the conduction. L is 5 centimeter and 1 centimeter. K for this part here, given 61. For the other part, for the insulation, you have data, you have another data, you have different data. So you have different resistance of all of them for the second one. Okay? And that is why TS for you different than TS for your friend, different than TS, because different data.
Doctor, can I use T for the bottom surface?
Yes, what do you mean? Tn? Yes, Ts minus Tn. Yes, of course. You can use it. Because Ts minus Tn here in the denominator. In the denominator, you have two resistances only, the conduction one. So whatever you wish to use, any equation is fine. But again, you have to assure that there is no missing data other than TS. That's the point. Because the easiest equation is with the top. This is the easiest equation. You have one resistance, right, between them. But unfortunately, we cannot use it because we have two unknowns. So this outside resistance, we edge here at the outside, which is we don't have it. There's the second one also is easier, okay? Go to the third one, the air velocity. You need the air velocity. Okay. Now this is the hard part. To find the air velocity, here opposite to what we discussed it means we use same concept but opposite way. Remember in chapter 7, what we use, we have the velocity, we calculate the number, and then we calculate Nusselt number. Here you go back, calculate Nusselt number from edge outside. So first you have to find edge outside from the resistance. After you determine TS, you can apply Q equal T fluid 2 minus T fluid 1, or T fluid 2 minus TS, or T fluid 2 minus Tn, whatever. Okay. All the temperatures now known. Correct? Delta T over the total resistance. Then find the resistance. This is outside. So the resistance outside, you can't find it. Okay? Now the resistance unknown. Delta T over resistance. Okay? T fluid 1 minus T surface over resistance is equal to Q. Right? Q known. T fluid 1 known. T surface known. After this part. Or apply T fluid 1 minus T fluid 2 over total resistance. T fluid 1 and T fluid 2, both of them given. Q known. So you can find the total resistance. Minus 1, 2, 3, you come up with the unknown resistance. Unknown resistance is 1 over edge A, right? Calculate edge. Once you know edge, apply Nusselt number, equation of Nusselt number, edge L over K, calculate Nusselt number, okay? Then apply Nusselt number for laminar or for turbulent. You have equation between Nusselt number, Reynolds number, and the Prandtl number. Calculate Reynolds number in this case. Because Nusselt number now known, you calculate what? Reynolds number. And from Reynolds number, you calculate the velocity. Because Reynolds is what? Velocity times length divided by viscosity. Okay. All the properties here mentioned. Go to table I5. Bring all the properties. So, as I said, this part is the hardest part. Go back, find first Nusselt number from edge out, convection outside, because edge here unknown, okay? And edge from the resistance. After you determine the edge, apply the equation of Nusselt number to calculate Reynolds. Now you have equation, remember, for laminar, and you have equation for turbulent, and you have equation for laminar plus turbulent, right? So you say, okay, what I have to do, which equation I should use? Here you have to make assumption. To make assumption. For instance, start assume laminar. Assume your flow laminar, okay? Then apply the equation of laminar. After you apply it, you calculate Reynolds number, right? Check Reynolds number. Is it greater than 500,000 or less than 900? If it is less than 500,000, it means your assumption correct. Right? You don't need to repeat or to, because this is assumption. Your assumption. If it is more than 500,000, it means the Reynolds number here is turbulent. So you have laminar plus turbulent, right? So you have, let's see here. Is your flow laminar, turbulent, or combined? You assume it laminar, but after you calculate Reynolds number becomes more than 500,000. It means your assumption wrong. Your case is not laminar. It's what, either turbulent or combined. Because smooth surface, look, is what?
Smooth.
It's not turbulent, it's what? You know, turbulent if it is rough it is from beginning to the end turbulent, right? So your case either laminar or combined. You assume laminar, you determine Reynolds number from the equation of laminar. After you calculate Reynolds number becomes combined. So you cannot, it means in the first case when you apply the Nusselt number is wrong. Because your assumption is wrong. So you repeat calculation of Reynolds number. You repeat it. How you repeat it? You go to the combined equation and apply the Nusselt number to calculate a new Reynolds number. That is your actual Reynolds number. Once you know Reynolds number, you can find velocity. Because Reynolds number is velocity times L over viscosity, you know that. And of course, you can answer right away, part D, which is very easy. If your assumption correct, it means your flow is laminar. If your assumption is not correct, it means combined. Okay.
Doctor, you said the viscosity and the density.
Yeah, all those property, viscosity, and you have to go where?
It depends which temperature.
Okay, here it is. At film temperature between the surface and the fluid. Part B, find what?
Yes.
Assume TS, let's say in your case, for example, 30. 30 plus 55 divided by 2. Go to the table, 15, and at this temperature, at the average temperature, find all the properties. Okay? Because before you come to this equation, to this part, you have first to find the surface temperature. Because the property you need it where? Here. You need the property here, not here. Here, you apply chapter 3, remember, chapter 3, resistance. And resistance, as you did in the exam today, you don't need any viscosity or whatever, right? So you, after you determine TS, now TS known, TS plus T fluid divided by 2, okay? As I said, 30 plus 55, that becomes 27, then round it to 25 or 30. Because in the table, I think 5 points or degree or 10 degrees, anyway. Okay, yes.
Doctor, about the result, how we avoid missing point? I know you are strict about the rounding number or the number, I mean the answer.
Okay.
How to get full mark? يعني.
Okay, if you want to get full credit, look what you have to do. Use after point, another 4 digits after the decimal, 4 digits, okay? Not including zeros. If you have 0, don't include it. Let's say, for example, you have 0.000 and then 1, 2, 3, 4. Those zeros, don't count it. You start from the first actual digit and then count 4.
Okay.
If you do this, that's it.
Doctor,
Thank
we don't need to do an interpolation the table or.
No, you do, of course, if the temperature here, because look, you have first to go to the table. In the table, you need the table of the properties, right? So in the table, is it 5, or 10 degrees, or 50, maybe 50, for example, the table. At 300, at 20 Celsius, this is the property. Then at 70 Celsius, this is the property. This is big difference. Here you have to make interpolation. But if the temperature becomes 69 and you have 70 and 20, 69 is close to 70. You don't need to make interpolation. You have to judge this. Okay, you have. And that's why when I say take home, you have a chance to talk with your friend and even to talk with others outside. Right? You can't talk to them about this approximation, for example, of the temperature, if the film temperature, if it is accepted. As I said, I will not answer any question in this regard. You have to decide. Now, here is what the difference between all of you. 2 values, L and K. Remember, L, K, let's say start with K. K of insulation will affect TS.
Yes.
So TS of you different than TS. All of you have different surface temperature. Okay. Although you have same temperatures from inside and outside, the surface temperature that you are, what you have, all of you, different from each other. All that because of one thing, because of the conductivity of the insulation. Good. Okay? So now, TS, this part, and the rate of transfer as well, all different between you. Okay? First. Second, because L, also that the missing one, data is given different between you and your friend. When you want to calculate, remember Nusselt number, H times L over K, you have different H and you have different L. So you have different Nusselt number. You have different Nusselt number, you got different Reynolds number when you apply this part. So maybe your Reynolds number laminar, maybe his Reynolds number combined. So if you see your friend, his Reynolds number is laminar, you know, you start by assuming all laminar, because this is the easiest way. It doesn't mean your friend laminar, it means you have to be also your laminar. Okay? This is not the case. You may be turbulent because you have different L. So different Nusselt number, okay? If you are laminar, as I said, and then you calculate Reynolds number, and number less than 500, it means your assumption is correct. You don't need to repeat the calculation of Reynolds number. But if your case, Reynolds number, after determining Reynolds number by assuming laminar, you end up with more than 500,000, it means that your case is not laminar, is combined. So you have to go back and apply the equation of combined to calculate a new Reynolds number. And that, of course, that new number will be more than 500,000, but different value. Okay? And then use that to calculate the variable. And again, keep the velocity you got it in meter per second. You have to convert it into kilometer per hour. If you don't convert it, you lose points. Oh, and of course, if your case laminar, you say laminar, because it's not number. Okay? So here is the information you needed. Thickness known, temperatures, L, as I said, you will get it tomorrow morning, you will see it, or today after midnight. What else you need? L, as I said, and K. K for the brick parities, 61, and the temperatures, as you see, 14.5, 12. What else? Yeah, that's it, I guess. Look, the only thing that equal to all of you is the first part. The rate of heat transfer through the roof, okay? Same for all of you for a steady state. Because you can't get this from convection. And all values are fixed for all of you. 14.5, 14, and 12, right? Remember, the next has no any relation. So the first part should be same for all of you. Because you just apply one equation. The remaining, different. Okay. Any other question? So now, the submission on Monday, next Monday, okay? On the class, of course. If you submitted late, one day, if for example, if I come on Wednesday or Tuesday or Wednesday, then I see any, let's say, papers under my door, you will lose 5 points, at least. So please try to finish it before Monday, because you have a time if you want to check it with others, okay? Because if you start on, let's say, Sunday, and then you don't have no time if you made any mistake, again, that hurts you, right? So start, for example, on, let's say, Thursday or Friday, finish it within 2 days, right? And then use Sunday, right, to check your, with others, as I said, inside or outside. This first. Second, don't skip any step, okay? Don't skip any step. This is take-home exam. I need complete solution. Put the equation, put the numbers, and find the result. Don't skip, you said, okay, by calculator. Because this is not in an exam. Here you have a time, here you have a week. Okay? So there is no such. And careful about the units. Meter, stay in meter. This is the width. Remember, in the area, HA delta T, right? The width is 3 meter, and the length L, 3 is for all of you, but L different. If you know that.
So Dr. solving by the calculator is not allowed for there's like a variable and long equation?
Yeah. Because you don't, look, the equations that you have, it's very simple and have one unknown, and linear. So there is no such complicated equation. For example, you have, let's say, complicated, sine or cosine or whatever. You don't have such issue. You have, for example, 1 over x equal a number. Then you can calculate x easily. Okay? So this type of equation is simple. And as I said, all of you same steps. All of you, similar steps. You start with all of you with same. And even the analysis, similar to all of you. The only difference, the numbers, the numerical value. Okay? And the difference here. If you are laminar, if you assume laminar and you end up with laminar, it means that it will stop. If you are assume laminar and you end up with turbulent at the Reynolds number, you have to assume combined, means you have to repeat it again. Because your actual assumption should be combined, not laminar. That's the only difference between one. Okay? So that's worth 15 points. I'm sure all of you can get the full credit.
Thank you.
Okay?
Inshallah.
And that's it. Once you submit this one on Monday, you don't need to submit only one assignment. I guess assignment When you want assignment, Nick? 5, when? Wednesday, this Wednesday? 28, this Wednesday. Okay, so if you submit it today, that's it. Once you submit
Next Monday.
next Monday the take home, you don't need to care about heat transfer until the final exam, because there is no exams, no assignments. If you miss before an assignment, you have to submit another assignment later. If you full submitted your assignment fully, you don't need to care about assignment 6 or assignment 7.
Thank you.
Any question? Or you have to make interpolation?